talk about secret management with Hashicorp's Vault. Quickly about me, I'm a senior consultant and part-time at innoQ. Rest of the time, I spend my time on playgrounds. When I'm working, I focus mainly on DevOps and continuous delivery topics. The focus of this talk is to introduce Hashicorp Vault. Quick show of hands, who has only just heard about, not just, but who has only heard about Vault? Okay, did somebody use it to play around with it in development mode? Okay, and who uses Vault in production? Excellent. Nobody, nearly. Cool. So the topic of this talk will be explain what Vault can be used for. Perhaps you already think about using Vault, but don't know all the usages that you can use it for. Then I'll explain the Vault components, which is basically the auth backends and secret backends and Vault policies. And I will not show, but tell a little bit how we used Vault in some of our projects successfully. The focus is not to explain the Vault architecture, like how Vault works internally. I will not talk about how to do a highly available setup. I will not talk about which persistency options are the best. And I will not talk about how to set up Vault for production with certificates. There's excellent documentation on the Hashicorp website for that. So the executive summary for Vault, it's a tool for managing secrets. And if you ask yourself, is Vault useful for me? If you ever had the problem that you wanted to deploy an app, but you didn't know where or how to save, for example, the password on the username for a MySQL database, you probably need a secret management system. What does Vault give you? It secures, stores, and tightly controls tokens, passwords, certificates, API keys, and other secrets. And the other secrets is actually the most interesting part. It handles for you leasing, key revocation, key rolling, and auditing. So if for compliance reasons you need an audit log where you can see whenever somebody requested access to a database, Vault got you covered here. It provides a REST API for all those operations. And just to be clear, Vault is not meant as a service which sits between your request-response cycle of your apps. So Vault is not there to do OAuth authentication or authenticating the users of your apps, because sometimes this confusion comes up. So Vault is just there to manage your secrets. In its easiest form, Vault is basically you somehow authenticate at Vault with a, for example, username and a password, and on the other side you can read some secrets. This doesn't really sound super exciting because now we swapped one pair of credentials with another pair of credentials, and even if you can read more than one secret, it's not a good sell yet. What Vault provides you with, though, is that you can authenticate with very many different methods. And there are methods for users and methods for deployed apps. And instead of just static secrets, actually a pointer work on this thing? No, it doesn't. So instead of static secret console, Vault can actually create dynamic secret, which is actually the most useful part of Vault. So we'll first talk about the auth backends here, like the way I or apps can authenticate with Vault. So the first and most basic authentication is just a token. Tokens are always created by Vault itself. You cannot say, I want to have a token with foo bar that works. They are always created via the Vault API, and the only way to speak to Vault, like to read secrets, is to use a token. All other authentication methods are just there to authenticate you once and get a token in return, and use that token then to speak to Vault. So this is like how a token looks like. It's like a UUID or something. Tokens always have a time to live. So this token is invalid after 5 minutes. They can be renewable. So if set, you can renew the token, and there are two modes. So either you renew it and you get a new token, or you renew the token itself so the token doesn't change. And every token has policies attached to them. So policies decide, like once I authenticated against Vault, I cannot just read everything from Vault, but you have certain policies that tell you, for example, like app 1 can only read the database password, which is for the database used by everyone. Another possibility to authenticate against Vault is with the username and password. So for that, you have to configure Vault once initially. You will always see that we use something like paths here. I will explain that later. Just ignore that for now. But in this example, some administrator, for example, creates a user named foo with the password 123. And then if I want to operate with Vault as a user, I can actually authenticate with foo and password 123, and Vault returns a token with some policies attached to it. And from now on, I can talk to Vault and read the secrets I'm allowed to read. So this is for users. The next authentication method is for like human users as well. Well, not only human users, but yeah, it's a very static authentication method. That's TLS certificates. Again, here I configure Vault, give it a CI certificate in the configuration, and then a client comes along, passes a client certificate. If the certificate was signed by the CA, then I get a token and I can talk to Vault. So those two methods are not really exciting. What is very handy actually for developers or administrators is if you use external identity providers in order to authenticate yourself against Vault. There's, for example, LDAP, Radius, and OctaAuth support. The last two I actually don't really know, but most of the companies have an LDAP set up. And what you can do now is, like, as a user, you provide your LDAP username and password to Vault. Vault checks against LDAP if the combination is correct. The LDAP in the response returns the username and the groups the user belongs to. And depending on those two, like user and groups, Vault returns a token with some policies, and then I can talk to Vault and, don't know, read database credentials or set database credentials and so forth. This, of course, doesn't work out of the box. For this, you have to configure Vault. This is one of those examples. To configure an LDAP, it's kind of straightforward. You get the LDAP address. Then there's some LDAP foo I don't really understand, but your administrator of choice usually knows his way or her way around it. And then down here, you actually do the mapping from LDAP groups to Vault policies. So in this case, if the user Kesselborn logged in and is part of the group employee, the token would have the policies employee and admin attached to it. Like, as I said, tokens can have multiple policies and they all add up, and the mixture of them decides what you can read and what you are not allowed to read. GitHub Auth is actually the same idea. Instead of groups, it's teams, but the rest of it is true as well. Interesting for the question, like if you deploy an app, but you don't want to store any credentials anywhere, is, for example, if you run on AWS, is AWS Auth. So the scenario here is I have an app deployed on an EC2 instance, and this app needs a password for some external service. I don't want to save any credentials anywhere. I just want to use what is available on this instance. And just if you're not familiar with AWS, I don't know if I'm always standing in the way. If you're not familiar with AWS, each instance in AWS has a meta service that is available on each EC2 instance. So on every instance, you can actually query information about the instance itself. And part of this is, for example, an instance ID, an Amazon internal instance ID, the private IP, and a few other interesting information. And the interesting part here is that this identity, the instance identity document is actually signed by a private AWS key. And we can use that for Vault to authenticate. Because if you pass on this document, Vault can actually check if the signature is valid by using the well-known AWS public keys. So Vault can verify that this document really comes from AWS. And the next step, it can verify that the instance that we run is allowed to get access to Vault. You do this by instance profiles. If you're not familiar with EC2, that's something like you can tag your instance and Vault can check, okay, does the instance have this tag? And if that is true, then Vault generates a token, again, with some policies applied, and your application can then speak to your database. One optional feature of this, but I think that's the default behavior, is that now when one process of that instance used this authentication method once, this instance is on a blacklist in Vault. So with this, you can avoid that any process on this instance which runs later can do the same dance here and authenticate against Vault. So you can only do this once. The idea behind is that early on in the boot process, you have a small app or daemon that starts up, authenticates against Vault, and then handles the token, and afterwards nobody else can do the same authentication. Another method which does something similar for a project called Kubernetes is the Kubernetes auth in Vault. It's actually very similar to the AWS. The difference is that instead of a metadata, it uses, that's not really readable. Can I zoom up? No. Well, it uses like every container in Kubernetes has a token of the service account mounted within the container. Every container has that under this part, which is well readable on a var run secrets Kubernetes IO service account and then token. There's a token which belongs to the service account this pod is running under. So and here as well, you can take the token, you pass it on to Vault. Vault then queries the Kubernetes API whether this token is valid, and then gets a reply, a success or failure with the information about the service account name and the namespace this pod is running in. And depending whether this is whether we allow this in Vault or not, it returns a token with some policies attached to it. I go in some detail now because this container days, like how we implemented this in one project. We did this authentication flow in an init container here. So do this, you have the token, and then the init container stores the token on a volume, which is shared by the app, which later starts. So when the init container is finished, the app now has a Vault token on the HUD or on the volume, and can use this token to talk to Vault. And as there's no configuration necessary in order to do this authentication flow, you can just use the same init container in every app you have. There's no configuration necessary. That's a very convenient way to do this authentication. Here as well, how do you configure that? It's actually pretty simple. You pass it the host of the API and a CA certificate so that you are sure that Vault always talks to the correct Kubernetes API and to avoid man-in-the-middle attacks. And then you map like the Kubernetes service account and optionally the namespace as well to some Vault policies and give it a default TTL. If you're not lucky and you don't run neither on AWS nor on Kubernetes, there is still another authentication method that you can use that gives you a similar way to use Vault with your applications. So a scenario here is you have an app, again you want to read some secrets, and you have some external orchestrator, which could be, Kubernetes if you don't want to use Kubernetes auth, or Marathon or just Chef, Puppet, or Ansible. So you have some process that can already talk to Vault, and you have the app. App role authentication works with a role ID, which is like a static string, which you can check in to the repository of your application, because with just the role ID, you can't really achieve anything, and a secret ID. And the secret ID is always created on the fly. So if we do a deployment now, your orchestrator requests the secret ID from Vault. It has to have the rights for that. I left the authentication for this process out here. Gets the secret ID, and then during deployment, injects the secret ID to the app via environment variables or file or something. The app then takes the role ID and the secret ID to authenticate against Vault, and in return gets a token and can then speak to Vault. The secret ID is only valid once. So once you use it once, the secret ID is not valid anymore, and somebody who has the rights to do so has to create a new secret ID. So those were the auth backends. So now you have different ways to authenticate against Vault. And now that you are authenticated, you probably want to read some secrets. And as I said, there are static secrets. Those are the boring ones. So let's get out of the way with them. Static secret means some administrator or some developer writes, for example, an API key to Vault with the content 1234 foo-bar. And now an app, on the following slides, I leave authentication out. I always assume that somebody who talks to Vault is allowed to do so. Now the app can read the same path here and gets back the content of the document. And everybody's happy. The more interesting part is the dynamic secrets. Dynamic secrets means that the credentials that the user or the app reads from Vault are created on the fly for each app and user who wants a secret. They're usually short and or medium long TTL'd, so they're not valid after 1 hour, let's say, anymore. And they are fully audited as well, so they are all in the audit logs. And how does it work? Because like Vault needs to know somehow how to create, let's say, a dynamic secret for my SQL database. The strategy is for all the dynamic secrets is very similar. First of all, you provide Vault credentials for a user that has rights to create tokens or a username and password. Second, you configure Vault with settings on how to create the credentials, because just because we are allowed to create users for a specific database, we still don't know what rights the user should have. I will have a complete example. And third, optionally, if that is necessary, we have to configure Vault and tell it like how to delete the user again. So we'll start with databases. I think that's the most common use case. Like support is involved is for Cassandra, HANADB, MongoDB, MS SQL. So the big SQL databases here. So first step is like some administrator or developer configures Vault. I have an example here. So you tell it here for the client's database. It's a MySQL database. The connection URL is like user and password given. So they have to have the rights to create new users. This is the host. And then you have the allowed roles. It's clients are O, clients are W. So we have like read-only access now and read-write access. And these roles are defined here. So now you have a role, and this is like the statement on how to create a new dynamic user for this database. You say, this is a little template, right? Create user, the name is created by Vault. It's a random string. Identified by the password, which gets created by Vault again. And now I do here grant select on clients, which is the database, to the user. If I had to read-write user, I would grant select, update, delete, insert and replace on clients. Yeah, and there I can define how to create the dynamic secret with a TTL of 1 hour and max TTL of 240 hours. So there's actually 2 settings. I think the first one is like how long you can log in with this user. Afterwards, the password will be changed to a random value, and the max TTL is how long the user actually works within the database. So after 240 hours, even if I'm already logged in, the connection is active, the user gets deleted and the app cannot work anymore with this database. And then, yeah, app just reads the credentials for clients read-only. Then Vault creates the user for the database. Database returns OK. And Vault returns the login and the password for this database. And the app can now speak to the database. For MySQL or other systems which don't have like time to live, don't know about time to live, when the TTL is over, Vault will automatically go to MySQL and delete this user. So the user doesn't exist anymore. Okay, another secret backend is AWS. That is like we had AWS authentication earlier. Now we want to give access to AWS to users or applications. The configuration is more or less the same. You provide an access and secret key for AWS to Vault, so Vault can create IAM users and or STS tokens. Then my app goes along and says, read credentials def, for example, so the role is called def. Vault creates a token or an IAM user. You can do both. Tokens, I think, are the preferred way to do that. AWS, in this case, already knows about the concept of TTL, so the token you get from AWS already has a TTL assigned to it, and this token is then forwarded to the app and works. Secret backend PKI, like private key infrastructure. That is for creating client credentials on the fly. Configuration phase here again is very similar. You configure Vault with a CI certificate and a CA key. Then if you want to issue a certificate, you write to PKI issue def. Vault will create a client certificate for you and will return the certificate, which can be used by the app. You can actually use this, we use this in a project to do the kube control or kubectl, I learned on this conference, however it's pronounced. Like you have the configuration for Kubernetes, and that usually works with client certificates. And what we did, we created a client certificate which only is valid for 18 hours. So when the user is not anymore in the LDAP, he cannot use Kubernetes anymore. Nearly last secret backend I want to talk about is SSH. You can actually provide SSH access via Vault as well. Once configured, there's different modes. I will talk about the one-time password here. You write to SSH creds def and give it the IP address here, and Vault creates on the fly a username and a one-time password. With this username and one-time password, you connect to the host, but of course, with plain SSH, the host now wouldn't know whether this is valid or not. So on the host, there's a small agent which talks to Vault. So it takes the username and the password and the IP and verifies with Vault that this one-time password has been created for this instance, and if the case, it grants access to the host. One last thing is the transit secret backend. Like if you just want to encrypt or decrypt documents, there's an endpoint for that as well. Like if you are allowed to write to transit encrypt app foo, for example, the text foo, Vault will return an encrypted document. It will not store the document, it will just encrypt it and return it to the user or the application who encrypted the document. And now if somebody or some app or some user later needs to decrypt the document, you just write to the path which is decrypt, send it the encrypted document, and as a result you get the decrypted document. So as I said, for this mode, Vault doesn't store anything apart from the private key it uses for encryption, and the private key never leaves Vault. So basically use whatever the author you want to read secrets. And one example from the project that we did, like developers, they authenticated with LDAP and then got access to AWS. They got access to configure, fill, and read from databases. They could read and set static secret like API keys and could connect to via SSH to different hosts. Whereas the applications, they used the Kubernetes authentication, and then they got access to databases, they could read static keys, they had a private key client certificate in order to speak to a broker in the backend, and they were able to decrypt some documents. So the last part is the Vault policies. How do the policies work, the access management? And for that, we have to understand like how Vault exposes its secret to the user. So it's like a file system, and that's why for all the examples I had, you always saw something like a path in the file system. And for static secrets, that's quite straightforward. Let's say you want to save an API key. You have some hierarchy here. It's my team. It's app1, API keys, And there's one for Google Analytics and one for PayPal. That's very straightforward. But Vault actually organizes every secret backends like this. So if I want to read a dynamic secret for my database with a client's read-only configuration, I would just read database creds clients-ro. And now I can apply the policies based on a file path, and it supports wildcards as well. And there we have the usual suspects of verbs. We have create, read, update, delete, list, sudo, and deny. I think everything apart from sudo should be more or less self-explaining. And the sudo I will leave out for today. Yeah, it's for the Vault user management itself, so that you don't need always the Vault root user who is allowed to do everything, but you can give sudo rights to other Vault users. Yeah, then writing those policies is actually quite straightforward. So now here is the policy for my app 1. I want to allow it to read every secret under team app 1. So we use a wildcard here, and we are allowed to read and list. So here in the file path, you can see like here, you can see like read and list. And then we are allowed to read a new certificate, which is under PKI issue broker. And we are allowed to read the credentials for the database, but this app apparently only has read-only access here. The developer for app 1 has much more permissions. Developers can actually read, list, create, update, and delete static secrets. They can configure the private key infrastructure. They can configure the database clients, and they are allowed to SSH into machines. Okay, as a recap, how Vault works, you authenticate somehow, get a token with some policy attached to it, which again allows you to read some secret. That's the whole magic sauce with Vault. And now, as always, I'm earlier finished than I thought. And I can now speak with 10 minutes about it that we are hiring. No, sorry. We are hiring. We have an office in Hamburg now, Berlin, Munich, Frankfurt. And now I'm open for questions. Finished.